Via Marina wishes to contribute to reducing inequalities between regions rich in water and those suffering from water shortages. To do that, Via Marina has developed its proprietary system for transporting water in large quantities and over long distances by underwater flexible pipe. This system of submarine rivers is called Submariver. In many places in the world, coastal regions suffer from a shortage of water. However, rivers in other regions pour large quantities of fresh water into the sea. The idea is to take water at the mouth of these rivers. The water removed in this way is transported via a submarine pipe. On arrival, homes, agriculture and industry benefit from the water delivered. This gives rise to a strong economic and social development in these coastal regions. Water is removed at the mouth of a river, just upstream from its salt wedge. Only a small fraction of the residual flow is taken at this point in order to limit the impact downstream on the ecosystems of the river mouth. A small dam diverts the water to be transported. A pipe or land canal brings the water to the coast. On its way, the water undergoes a slight treatment to avoid it transporting suspended solids or microorganisms that could damage the submariver pipe. The water is then pumped at the pressure required for the distance to be covered. Anti-water hammer devices ensure the safety of the system. In the departure shore approach, a jetty protects the pipe until a certain depth and a certain distance are reached. Beyond that, coffers protect the pipe until another depth and distance are reached. These depths and distances are calculated so that the pipe does not obstruct surrounding human activities and so that such activities do not threaten the pipe. Fishing, leisure activities, maritime traffic and other elements are to be taken into account. The pipe is then laid on the seabed. When possible, it is placed on the continental shelf at a depth of about 200 meters. However, there is no technical limit to the depths the pipe can travel over. The cost is higher when the depth is greater. On arrival, the same systems protecting the pipe at departure point are present at the depths and distances required locally. Also present are the anti-water hammer devices and the intermediary storage tanks from which the connections to the different distribution networks are made. The water thus delivered can be used directly for agricultural purposes. For domestic or industrial uses, it has to undergo the usual treatments. The pipe is laid with its ballast from a laying barge. This barge is fed as it progresses by supply boats, which work in relays to and from a nearby port. The laying barge goes forward at a speed of about 5 kilometers per day. This ensures the submarine route is rapidly undertaken once all engineering studies and the building of the onshore works have been completed. The laying is carried out without any preparation of the ground. The diameter of the pipe can be as large as 4 meters. Submariver can therefore transport several dozens of cubic meters per second while using up very little energy. The pipe is very light and totally flexible. It can collapse and then swell up again. The pipe is made mainly of very highly resistant thermoplastic textile fibers similar to Kevlar. The fibers are covered with a special coating on the inside to ensure the pipe is waterproof, and on the outside to protect it from the aggressive marine environment. The materials used in the pipe comply with all regulations on food contact materials. Since fresh water is being transported amid salt water, the pipe has a natural buoyancy. It therefore has to be ballasted. The ballast also serves as an anchor against marine currents and swell, even if these constraints are alleviated by depth. The pipe is linked to the ballast with straps. The length of the straps is calculated so that the pipe floats at a certain distance from the sea floor. Thus, Sub-River can easily be adapted to the contours of the seabed. For reasons concerning the safety of delivery, Sub-River envisions laying 2 parallel pipes. They are situated at a good distance from each other to minimize the risk of an accident taking place simultaneously. If the transport distance is very long, it is preferable to bring the pipe up to shore approximately every 200 kilometers in order to provide again the required pressure into the pipe. These intermediary stages can constitute additional water catchments or else extra delivery points. It is thus possible to cover more than 1,000 kilometers economically. The main advantages of Sub-River are provision of very large quantities of water, low energy consumption, very economical transportation price. These advantages make it possible to satisfy not only human consumption, but also agricultural needs. This is essential since agriculture is going to have to consume more than 2/3 of the world's water once the 3 billion extra individuals soon to be born on Earth have to be fed. These submarine rivers can therefore contribute to solving the problems of water and food in the world. Many countries are seriously studying Sub-River with Via Marina for a forthcoming implementation.